Have you ever tried to predict the future? Well, meteorologists do it every day, but instead of looking into crystal balls to decide if it's going to rain, they turn to science.
Forecasting the weather starts with understanding what's happening right now.
First step in starting a forecast is taking a look at satellite imagery and also surface observations.
And, of course, meteorologists use data from weather balloons. I recently got the chance to join the National Weather Service office in Shreveport for their morning balloon launch. That's the sound of hydrogen, which is used in place of helium. And these balloons need to be tough to withstand the different layers of the atmosphere. That's why they're made of a latex blend that can stretch as the balloon grows. As you go up, pressure decreases and the balloon expands. And by the time the balloon reaches the top of the atmosphere,
these can get to the size of a school bus.
But even on the ground, they're huge.
I mean, look how big these things are. Weather balloons are launched twice daily, and they collect humidity, temperature, and barometric pressure as they go up through the different layers of the atmosphere.
3, 2, 1, let her go.
This process is repeated twice a day by over 90 locations across the U.S.
All the stations are launching at the same time because we're trying to get the same snapshot of the atmosphere at the same time.
That three-dimensional snapshot depicts the jet stream and other driving forces of our weather pattern. All that information, along with other data, is then plugged into a weather model.
Numerical weather prediction is the formal term for all of the weather models that you might see on TV or someone might be talking about.
A weather model is a computer program, just like Excel or PowerPoint, but it's much more complex. It takes what is happening right now and runs through a complicated set of equations to predict what might happen in the future.
Taking that initial state of the atmosphere, we can use very powerful computers because this is a very intensive process.
The model simulations give one possibility of what our weather might look like at any given time in the future. And for the most part, they're pretty accurate. But sometimes the models can make mistakes.
Mother Nature likes to throw monkey wrenches at us from time to time. And so because she does not necessarily cooperate the way the models describe her to be.
Model errors can happen frequently in difficult to forecast areas, like Texas. Instead of just relying on one weather model's output, Texas forecasters need to use multiple sources to make an accurate 7-day forecast.
But a lot can change in 7 days. Have you ever checked the weather and thought it would be sunny all weekend, and then looked again on Friday and saw rain in the forecast?
That happens because a forecast becomes less reliable the farther away it is.
7 to 10 days, there's a pretty good idea of where the biggest troughs and ridges and lows and high pressures are going to be. But as you get to the smaller and smaller scales, that's where the time frame in which we are certain of what's going to happen is closer here.
10 days away, we can only see the big features, but the small details are pixelated. As we get closer, the view sharpens and the forecast solidifies. A good rule of thumb is that weather forecasts are 90% accurate for the next 10 days. Beyond that, there could be some errors.
What people need to really realize is that weather is not and really will never be an exact science. That's why we introduce kind of ranges.
So instead of forecasting a 100-degree day, forecasters will say how likely it is that we reach 100 degrees. For CBS 19, I'm Sarah Blue.
Summer heat is coming, and we all want to find that perfect temperature on our thermostat to stay cool, and that means our air conditioner is going to get cranked up, and on some summer days it will get cranked up on high. But how do we know just how much energy demand we'll need from our air conditioners? Well, there's something that we can use called cooling degree days. What are cooling degree days? Let's use this example to explain. Let's say the daytime high, 100 degrees, the morning low was 60. That gives us an average high for the day of 80 degrees. 65 degrees is the temperature at which we think is most comfortable. So if we subtract 65 from 80, we get 15, and that's how many cooling degree days we needed for that day. When we add that up through the summer, then we know how much energy demand we needed to stay cool. Well, guess what? That cooling demand is increasing, and it has been since 1970, all the way through the latest data that we have in 2022. And it is expected to continue to grow through the year 2050, not only in American households, but also U.S. businesses. And one of the reasons is that we're seeing hotter days when we add in the heat and the humidity. In fact, 20 more days on average where that heat index climbs above 90 in Tyler. Typically, we get breaks at night when temperatures cool off. Well, it seems like since 1970, Overnight lows are getting warmer too by about 2 degrees, and in the United States that same trend is happening by about 2.5 degrees. So let's talk about those cooling impacts. The International Energy Agency says energy from air conditioners is expected to triple by the year 2050. Of course, we need air conditioning to work, learn, and be productive, and it keeps our food and medical supplies safe, right? Well, it also comes at a cost. Minority and low-income communities lack access to air conditioning, and it can be fatal in the summer months. Air conditioning powered by electricity generates fossil fuels, and guess what? That traps CO2 into the atmosphere, and of course that means air conditioners also release heat, which also traps heat in our atmosphere, and that enhances the urban heat island effect. So if we can cut our energy demand, we can keep those cooling degrees down, we can do something to help our environment.